So this is just a test video to look at the quality of the bamboo tablets, and also to get a better picture of the microphone that we're using. So as an example here, I'm going to select a little blue pen and we're going to sketch out the heart. So here you can see we've got a one-sided heart, and I'm going to go to grab myself a red pen. As you come across here, I'm going to press Ctrl and Z just to quickly get rid of that. So this is free software I'm using here called Smooth Draw. So we've got two sides of the heart here. The red is going to represent oxygenated blood. The blue is going to represent deoxygenated blood, so CO2. On the right side of the heart, now we've got left and right, appearing the wrong way around, but if you put it on the front of your chest, you'll notice that this side here suddenly becomes your left. We have a large entry point called the vena cava. And the vena cava would also come up inferiorly at the top of the right side of the heart as well. So you might see this point called the superior vena cava, and this component termed the inferior vena cava as well. If we were just to split the heart up, we add a bit more structure here. So I'm just going to break it down into equal proportions. As I'm writing this in a bamboo pad, I can lean my hand quite comfortably as I'm normally writing as well, to give you a bit of feel there. So these aspects are termed atria, and these are ventricles. So atria, we just remember A for above. So as blood, deoxygenated blood, comes through the superior vena cava as one example, it would enter into the right atrium. It will channel its way down the left ventricle. It would then go up to the lungs, where it becomes deoxygenated. I'm not going to go in detail here, I just want to demonstrate what I can do with this equipment. It comes back into the heart through the left atrium, and then is ejected from the heart via the left ventricle. This should be right, silly me. So this element here would be nice and thick. We might term this the myocardium. We also would term it, might be commonly known as the septum. So this ensures that deoxygenated blood here and oxygenated blood do not mix. So for example, if people are born with a hole in the heart, it's normally in this region here in the septum. In 98% of people, 99% of people who are newborn or babies, oxygenated blood flows through the septum and then shuts up, but for 1 or 2 it doesn't fully close up, and that's where that term comes from. If we represent the myocardium here on the left ventricle, it's normally very thick, because this is the part that's oxygen, and so it wants to be delivered out to the rest of the body. So it needs to be quite forceful. So this is kind of the first inclination of blood pressure as it leaves the aorta, which would be here. And we'll notice that the ventricle walls on the right hand side are not as thick, and that's because they are carrying more blood. They have to cope with more, so these walls normally can stretch quite a bit as well. Okay, we've got valves here, valves here. I'm going to stop the video there for this little example, but hopefully you can see the potential when using this software. So, ciao.